Hi everybody, welcome to the class number 10, to the third track about how we can apply artificial intelligence in container ports logistics, and especially we are trying to do some specific simulator about how we can simulate some operations in the container port. So let's put all things together. This class, we're gonna need a lot of previously class on this track. So if you didn't see the first track, it's important because we're gonna use the code to appears occur somewhere about the first track, and also we're gonna need the knowledge from the second track. It will appears occur somewhere. And finally, let's get all code together. Remember that in the description of this video, you have all things, all code available for free in the Google Colab environment. So let's see the code that we have to put all together. So I already have this from track 1. So let's start to execute this and put this in the memory. The definition of the container ship class. So this class enables us to just create the picture of a container ship and to put containers inside the cells. So okay, so let's load all loading and loading rules functions that we developed in the second track. Okay, so finally we have the simulator port. Let's put all together. So in the description of this video, you can find also the previously class code. So we're gonna start with the code that we developed in the class number 9. It will occur somewhere with this code. So this is the code, the function initial ship. This function is important because it will make it easy to us to just create an initial configuration of the ship to perform quickly tests. Okay, so this is the function that we can create some tests, but we will not test this code, okay? Because we already performed in previously class this test. So it's okay, this code is okay. So what we're gonna need also, we're gonna need the code from class number 6. This class is very important because we are already tested this. From an integer number, we can uh, decode this to three other numbers, which can be the combination of a series of other rules. Okay, so let's copy this. Just copy this. No. So this function is also important to translate integer number into numbers, integer numbers that correspond, that can translate into numbers that will be employed to the functions, names of the rules functions, unloading and loading functions. Okay, we discussed this on class number 7, how we can use the name, unloading rule, and numbers. And also we discussed this in the class number 8, which is about loading rules and numbers. So we can combine these numbers that we produced here with the names of unload and loading rules. Okay, so finally we have to copy this function, the combine from class number 3. So in the class number 3, we have this also this function, which is the paper of this function. This paper, this function is related with the transportation matrix that defines in a compact manner how many containers which destinations port 2, 3, 4, and 5 should be loaded in each port. So with this, we're gonna get a map of how many containers should be loaded in each port and which are the destination of these containers. So it's a very, very compact function that will help us to define which cargo should be loaded in each port. So what is missing here? What we should define? We should define a new function which will be uh, defined in this video. In this function is evaluate. Evaluate is a very important function because it will use as parameters the transportation matrix, the container ship object, the solution vector of solutions, and finally, the number of rules. How many rules we have for in terms of unloading and loading rules. So these four parameters are very important to operate this function. This function will return the number of movements performed by the container ship through ports during this travel through ports. So now we're gonna need the number of ports, and this list so has the number of rules that will be employed in each port, not each rules, but the number this solution. Let's write this. Suppose that we have this, so this means that we're gonna employ the first combination of rules in the first port, the first combination of rules in the second port, the second combination of rules in the second port, and the second combination of rules in the fourth port. So you can decode this number, integer number, into three more integer numbers. So this is the spirit of doing this encoding, okay? So we are applying now this. So finally, we have to create a loop, and this loop will be P means this is the symbol for port. So port in range to starting the port 1 and ending the port N. So this is the loop that we perform, okay? So this is very, very similar to the things that we define in the class 3. And as you can see here, we have port, we have the VEC. It's also, I can copy this, okay? But I will start from the beginning because we have already too much class, so it's difficult to remember everything. So this VEC, it's important because it's a list that explain to us which container should be reloaded, okay? So it's an auxiliary variable, and this X variable will be the result from translate number to rule. If you are in a port, you should transform this integer number that are inside the list. So, and this, you should translate each number into the combination of rules, okay? So now we're gonna use so 5 minus 1. Why this? Because this sol list begins the index in 0. So if variable p is index 1, this sol starts in 0, like that. Okay? So these are the index of these elements for to sol variable. So okay, let's remove this. Okay, so we can translate this, but for translation we're gonna need this information about how many rules we have in each stage, in each port. For example, we have unloading and loading rules. How many unloading and loading rules we have? This variable should be put here to get the right conversion in terms of integer number to numbers corresponding to a combination of rules. So finally, I have here the same thing that we made before. In the first port, we don't perform unloading rules, okay? Just in the second, in the third port, okay. So let's use this unloading rule plus we're gonna transform into a string the number inside the first number inside this list. This is a list of integer numbers which corresponds to the combination of rules in terms of number. So and then apply this evil rule. So after perform this, we're gonna get some important things here. For example, we're gonna get the number of movements. Okay, so we can get this vec list filled with the blocking containers and the number of movements that we perform during this unloading rule operation. Okay. Finally, after this, we should combine these blocking containers with the transportation matrix information into port P. And finally, this will return this list modified, okay? So it's okay. And finally, you can write this, okay, to make this explicit. Then this, we're gonna apply the loading rule with the number, with the second parameter, the second element of this list from translate rules, okay? And finally, we can print the rule, which is the rule that we are applying. We can also print here, not a problem. We can print here also, but I will print only there. So in finally, we're gonna get number of movements. Okay, and this will be equal to the S1 back. So it's not a very complete thing here. I know it because and number of movements here it's not good. Here we have this number of movements. We can have a kind of number of total number of movements. Let's start in 0, and this will be a kind of variable that will sum the total number of movements that we perform during this container ship travel, okay? So we can make this. So now we can control the number of movements that we made in each operation. And also we can return, your interesting thing here, to return just return the total number of movements and the container ship after doing our operations. How will be the container ship? So how we can use all these functions? Okay, so first, after doing this definition of this function, we are just fine to create a study. So ship is equal to initial ship and CS1 container ship 4. Okay. So we created the container ship. Now we're gonna set the cargo map of this container ship. And finally, this one. Draw this. Let's draw this ship. Okay, we finished this. What's most important? We can perform some tests using. Let's see what I have this. Let's use it. Let's use this. Okay. So okay, now we defined this transportation matrix for to perform some tests. Okay. So what we're gonna need here? Yeah, we get this. Let's see the value of more simple way to define this. Let's print and see if this code has something wrong or not, instead of waiting too much to see if there is some thing that we didn't. Okay, it's working, and see that we have reports. Okay, because the transportation matrix it's right about this. Okay, so port 2, 3, 4, and 5. Maybe it's not good this. We can define the number of columns as the number of ports to go, or okay, port 2, port 3, port 4. Okay, so we can sum. We have 4 ports, so we have to go to 4 ports, okay, because the first line is not the first port exactly. The first port we start empty the ship, just to simplify things and to make things that in a manner that we can understand. So it's the second, the first, yeah, it's the first port, but we are interested to see what happens until we arrive at the fourth port. Okay, so just to make some tests. Okay, finally, what we got here, we got this any rules, which can be defined like that. Okay, so in fact we have 2 rules, unloading rules, and 6 loading rules. So we can define this, and okay, so what else we're gonna need here? So let's see the evaluate function here. It's here. So we're gonna need transportation matrix. We already defined it. Oh, okay. So we're gonna need also the the solution. This solution can be very simple. Imagine that the solution is 1. So it's very deceiving in the sense that these are the possible rules that we can use, but this is the solution just for port 1. So imagine it, we are employing here. So if we are just to employ the solution for the first port, it's will be the solution for the first port only. And finally, any movement, PS1, evaluate, print. Okay, I understand that it's not very good, this code. We're gonna make in the next class a great effort to make this more organized and understandable. Okay, it's not working, and let's see why it's not working. Okay, so for port B, so when they try to use this information, okay, it said that it's not working because here, oh, okay, it's because this is a list. At this moment, this is a list, and we are trying to sum this. It's not right. It's just length. Now that's gonna work because the sol it just has the solution for one port, the first port. If we want to have solution for more ports, we have to put more values. Okay. Oh, okay. We are gonna need math also. Import math. I forgot to just import math. Import math library. Because we use it here math floor. Okay. Okay, it seems that are working now. Okay, so this is the solution. We apply the loading rule for the first port. Okay, And after imagine that we have this initial container ship in the port 1, and we loaded the cargo. We put more cargo inside using the loading rule 1. So this ship had been filled with more containers, 5 more containers. And as you can see here, we put more containers. That's okay. We can put more of a solution for example, 2 ports will be something like that. So we're gonna apply the first combination of rules to the port 1 and to port 2 also. So I don't recommend to perform too much tests at this moment because this code is not very good in terms of documentation. So what I mean here, this code at this moment, it's not in the right way to perform some tests. So we're gonna spend the next class to define a class named CS Container Ship Simulation. So in the next class, we're gonna use all things that we made, the all functions that we made at this moment. And most important thing here is okay. I understand how these functions cooperate, how these functions work, but I need some more details to make this code more understandable and to perform some more detailed tests. So in the next class, we're gonna make some important details to create a new class that will incorporate all these functions in terms of methods. And this will help us to understand and to verify how this code works and to perform some tests with him. So with it. So thank you for your attention. I hope you find this video interesting and useful, and see you in the next video. Bye.